Hey, sixth graders, it's Mrs. Johnson. Today you're going to be doing your gravity and motion notes. So you will need this screencast or the slideshow that looks like this, as well as your 1.4 gravity notes. Okay, you should have already made a copy of this. And as we go, you're going to fill in the yellow highlighted sections. Okay. So our objective is I can describe the effect that the force of gravity has on matter. And the essential question is, how do objects move under the influence of gravity? So gravity is a force, just like we've been talking about, okay? But gravity is actually a non-contact force, and that's gonna bring us to the next slide here, okay? So what is gravity? Gravity is the force of attraction between objects due to their mass. It is a non-contact force. What that means is that objects don't have to touch one another in order for the force to have an effect, okay? And we know this. If I am if I jump out of an airplane and go skydiving, right, the gravity is going to pull me down even though I'm not touching the surface of the earth, okay? Gravity is what keeps objects in orbit. So it's what causes the moon to orbit the earth. It's what causes the earth to orbit the sun. It's what causes the International Space Station and other satellites to orbit the Earth as well. And we'll learn about that at the end of this lesson, how those objects stay in orbit. So gravity is an attractive force. What that means is that gravity pulls everything towards Earth. It does not push it. So we call that an attractive force. Gravity pulls on all objects with the same force. On Earth, this force is 9.8 meters per second, or 9.8 meters per second squared. What this tells us is that all objects will fall at the same speed, okay? And something that's a common misconception is that objects don't fall at the same speed. And there was some experiments done. There was a famous experiment where different balls were dropped from the top of the Leaning Tower of Pisa. And it was assumed that the heavier or more massive an object is, the faster it would fall. But what was found out is that objects are all pulled towards Earth with the same force, regardless of their mass or weight. Now, we know that that's not always true on Earth, okay? And the picture on the side with the, I don't know if it's a pool ball and a feather, we know that if we drop those two objects, the pool ball would fall much faster than the feather. But really what's happening is the feather, because of its shape, is actually the air resistance is what's slowing it down. So if we took away all the air resistance, all of the objects would fall with the same acceleration, okay? And that acceleration is 9.8 meters per second squared. Okay, so this next slide, there's a video. This is really cool. So we're going to watch this, and this is going to show us how this is true.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built outer concrete skin, which is part radiation shielding and part an external pressure vessel. So this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest. Now, in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So, in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
We dropped 2 millitor in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6.
So they sucked all the air out of there.
4. Cameras on. 2, 1. Release.
Look at that.
They came down exactly the same. Wow.
Look
how they hit right there.
Exactly.
You can back on the side.
Exactly the same.
Feathers don't move, nothing.
Look at that. That's just brilliant.
So pretty cool. That shows that in the absence, when we take out the air or when there's no air resistance, that objects all fall at the same rate or the same acceleration. This experiment was also repeated on the moon. Okay, and they found the same thing to be true, that objects fell at the same rate. So pretty cool. Okay, so that's our first big idea there, is that all the objects fall in the same rate. Second big idea here, all matter has mass, so every object exerts gravitational pull on every other object. Okay, anything with mass pulls on every other object. Okay. Gravity is not a very powerful force, but when enough matter gathers together, its effect can be very large. Okay, you can overcome gravity by jumping. Okay, if you couldn't overcome gravity, you would not be able to jump off of the ground. Okay, and gravity caused the Earth and the planets to become round. So when enough matter gathered together, it actually causes the planets to pull in towards itself and to become spherical shaped. Okay, so even though it's not a powerful force, when enough of it is together, it can be pretty powerful. All right. What determines the force of gravity? Well, gravity depends on two things. And the first thing it depends on is the distance that objects are from one another. So gravitational force between two objects increases as the distance between their centers decreases. What this tells us is that the closer together two objects are, the stronger the gravitational pull. The farther apart, the weaker the gravitational pull. Okay, this is why, for example, our moon orbits the Earth. Okay, because it happens to be the perfect distance away to stay in orbit. If it was any farther, we would have such a weak attraction that it wouldn't orbit the Earth. And if it was any closer, well, that could be problematic as well, because it would be a stronger attraction and it could come crashing into the Earth. The other thing that gravity depends on is the mass of the objects. So the gravitational force increases as the mass of the objects increases. What this tells us is that larger or more massive objects have more gravitational attraction, and smaller or less massive objects have less gravitational attraction. Okay, this is why if I'm sitting here at a table and my chapstick is next to me, the reason that the chapstick and I don't seem to have any gravitational force between us is because the pull of the earth itself is so much stronger, the gravity from the earth, because the earth is so much more massive than us, than me or the chapstick. Okay. And so the gravity towards the earth is more strong than it is for the chapstick to come to me. That's why my chapstick doesn't like stick to my body. Okay. Our masses just aren't big enough. We don't have as much of an attraction because remember, gravity in itself is not that strong of a force unless you have enough matter or enough mass, and then it becomes stronger. So the earth itself is the largest thing that we have on the earth, and so that has the strongest gravitational pull. The third big idea here is weight versus mass. Okay, a lot of times we use these two terms interchangeably, but they are not the same. Okay, weight is the force of gravity on an object. So weight is measured in newtons, or we use pounds here, but the standard unit of measurement is the newton. Okay, and so it's a measure of force. And so what weight is measuring is how much the gravitational pull or how much the gravity is pulling on an object. Okay, now obviously the more massive something is, the more it is also going to weigh. Okay, but your weight will change if the amount of gravity changes. So for example, if I went to the moon, my weight would be less because there's a less of a gravitational pull. If I went to Jupiter that has a stronger gravitational pull, my weight would be more because there's a stronger gravitational force. Mass, on the other hand, stays the same. Mass is the amount of matter, the amount of stuff in an object. Okay, so the amount of stuff that's in me is not going to change whether I'm on Earth, whether I'm on the moon, whether I'm on Jupiter. Okay, so mass isn't going to stay the same. And remember, we measure mass in grams or kilograms. But weight is going to change because that just depends on how much gravity is pulling on you. And we're going to do an activity later with this. How does gravity keep objects in orbit? So objects in space are moving in a way called free fall, okay? And so that's when gravity is pulling down in an object and no other forces are acting on it. So it's just free falling through space, okay? Orbit is when one object travels around another object in space. And the combination of forward motion, which is inertia, and downward motion due to gravity, so the free fall, cause an object to orbit, okay? So objects in space have inertia because remember, if you move, so Newton's first law tells us that an object in motion will stay in motion unless an outside force acts upon it, right? And so if, let's say, a satellite is moving or the International Space Station is moving, it's going to keep moving unless something stops it. Okay, and then if the gravity is also pulling on it, it's also what we call, we say that that's in free fall. Okay, and those two forces combined cause an object to orbit around something. Now the thing is that it has to be depending on the object's size and the object's distance from, let's say, Earth. Okay, it has to be the perfect distance away depending on its size in order to stay in orbit. Okay, and we will learn a lot more about this as we, when you're in 8th grade and you're doing earth science, okay, when we talk about space. But those two forces together, gravity as well as inertia or forward motion, are what cause objects to stay in orbit. All right, so your 3 big ideas here today, okay, we talked about how gravity pulls on all objects with the same force. Okay, and air resistance is what causes them to slow down. The second big idea was, let me back up here. The gravity also depends on the mass of an object as well as the distance between two objects. The third big idea is the difference between weight and mass. and then gravity can keep objects in orbit. So kind of 4 big ideas. All right, so make sure that your notes are finished, and then we'll move on to the next activities.